Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is Fieldbus technology still effective? And joining me today to answer this question is Duane Grob, Principal Engineer and Business Unit Director at Avanceon, a system integration and engineering services company. So thanks for joining me here today, Duane.
Oh, thank you. Appreciate being here.
So to get started, from the data I've been seeing, over the past several years, as much headway as Ethernet has been making onto the plant floor over the past decade, Fieldbus communications still remain a dominant form of industrial communications in place in most factories around the world. Now, based on what you're seeing working directly with manufacturers and industry, is that still true, or is that changing significantly yet?
Yeah, it's interesting. I think this is certainly true when you're talking about industrial systems that have been in place for a few years or more. The ubiquitous nature of Ethernet over the last decade or more certainly has outpaced various field bus installations. And to be honest, we rarely see other than Ethernet. The only small exception, I would say, would probably be for some small sensor buses like OSI or CAN bus. But field buses were the network of choice from industrial manufacturers, basically because of their dedicated and predictive nature. You could predict when the messages were going to get to your field devices, and the message packets were compact and streamlined for I/O applications. Ethernet, although relatively fast, was burdened with some metadata overheads, certainly some unpredictable communications, and potentially high loss of data in the transactions. And what happened is manufacturers of industrial communication devices quickly adopted the faster Ethernets and supporting protocols, and by building industrial-grade hubs and switches and routers and such that made communications more robust, predictable, and certainly less prone to drop data. There's a bunch of already ported field buses that most people are familiar with, and that would be like Modbus, Ethernet IP, and Profinet, which were generally field buses that have just the protocols have been converted over to Ethernet. Mm-hmm. There was a larger development community working on Ethernet evolution than there was on any specific field bus, and there still is. So at present, all the major manufacturers of field devices offer an Ethernet option, with some with multiple protocols over Ethernet. So engineers, developers, and the electrical support personnel understand that technology and generally have a fair amount of Ethernet already in place in the industrial landscape. They've already got SCADA HMI PLCs using Ethernet and have been for many years. So the knowledge base within the OT environment, within the plant maintenance groups, is pretty widespread.
One thing that you touched on there that I want to kind of just revisit here for a second, you mentioned about the preference for field bus early on was because of the guarantee of the delivery of the information as needed, when needed, between machines, between systems, whatever it might be. Mm-hmm. And I know that was a big knock on Ethernet early on, is that it wasn't truly deterministic like field bus communications. But there's been a lot of advances in that area over the past few years. I know one of the forthcoming ones is time-sensitive networking, but there's also been a lot of work on the protocols like Profinet and Ethernet IP and others to kind of ensure that determinism. Has that been largely effective at a level similar to what people expect and need from field bus, or is there still some differences between Ethernet and field bus on that front?
That's a good question too. The expectation from Ethernet is to behave as predictable as field bus. I think at this point, what you see is that the speeds of Ethernet certainly outweigh an awful lot of the other downsides, which is the packet sizes and the amount of overhead built into Ethernet. But the field buses themselves had such a streamlined packet of information, and they were easy to, and still are, easy to diagnose problems. But the amount of information available on Ethernet and the amount of information available within Ethernet certainly outweighs the, the, the small gains that some of these field buses have made over the decades.
So, is so much field bus still in place, across the globe in manufacturing facilities because it remains as effective as we were just talking there, and obviously would be costly to replace with Ethernet? Or are there other reasons that come into play for the continued prevalence of field bus?
Yeah, sure. The replacing field bus is generally not the primary reason to take on an Ethernet installation project. I don't recall ever having a customer say, "This my project is replacing field bus." Typically, they're looking for a way to replace devices, add devices, and they're looking for things that'll give them better information. And that's one of the reasons why they're going towards a more robust environment like Ethernet. So the option of replacing, or the reason for replacing field bus generally is coupled with a bunch of other things. You know, the desire to get more diagnosis and be able to do that over a consistent single medium is certainly attractive. The constant comments that I hear, and I'm probably sure most people who are listening to this right now hear that if you're going to do anything with field bus, the first thing you'll hear from anybody who has any responsibility for that bus will say, "It works fine. Please don't touch it."
Yeah.
And by this I mean, if there are modifications to be made to the existing field bus, really tread lightly or don't touch it. Yes, there's a fair amount of various field bus installations still in place, and a combination of reasons are really necessary to make that replacement viable.
Looking specifically at process plants, I know there's still a good bit of 4 to 20 milliamp communications used. Like as we've been discussing with field bus, do you see that persisting, or do you expect those to eventually move to a type of field bus or leapfrog field bus altogether and move to an Ethernet form for those sorts of applications?
Well, again, what we see is really an active attempt by manufacturers to get more from their field devices beyond the standard process variables and device actuations. This information is critical, and it's as critical as the operations itself. And those systems don't offer the ability to dig deeper into performance or the status of the field devices, and will likely leave the owners and the operators at a competitive disadvantage if they don't use this type of information. So once again, Ethernet, it's inexpensive addition to be put on smart devices and added to instrumentation. In fact, it's preferred connection in most standalone applications. This includes the ability to see problems arising and providing diagnosis before that takes the process down. So in this scenario, we seldom see field bus recommended if there is an Ethernet option.
Beyond the reasons we've discussed so far, are there any other specific reasons why a manufacturer would prefer to keep field bus communications in place rather than replacing it with Ethernet?
Now, believe it or not, there are some clients who are fearful of opening up their manufacturing or operational systems to the IT world. Ethernet is synonymous with the internet, and the IT departments may not be welcome into that world.
Mhm.
However, the line between OT and IT is a bit fuzzy now, and it's not as definitive as it used to be. Information in the OT world is as prevalent as the device controls. So information is not just an add-on, it's just as important as the device controls. Since these cases are few, I don't see Ethernet meeting resistance as perfectly acceptable field bus solution. Time will likely wear away and align all these things towards platform dominance, meaning Ethernet. The only thing that would slow Ethernet progression will be challenges in possibly bandwidth or reliability and security, but a lot of that is being handled within the appliances and the manufacturers, and they have been for years now.
So that's interesting that you're still seeing some of this, the IT, OT issues that we've all heard about for years now.
Oh yeah.
So that's still a thing. And are there because we see so many examples of where that has changed. Do you see this persisting? Is it in certain industry or certain types or sizes of companies where that's still an issue?
I can't say it's based on industry, but I think it is based on size. It based on size and strength of the IT groups generally. And I'm not putting down the IT group. They have, they bring a lot to the table. But typically speaking, if there is an Ethernet cable or there is, Wi-Fi, it's owned by IT. Even to the point where you have, um, SCADA and historian servers owned by IT. Therefore, the connectivity is owned by IT, and all of that is Ethernet.
Mhm.
And there are times when there were times years ago people were afraid to get IT involved because that meant that they were going to get exposure to the rest of the world because of the plethora of connectivity options within Ethernet. So the separation of IT and OT becomes more of a device or an appliance and an application responsibility, not so much who's doing the work.
Okay, thanks for clarifying that. So, other than facilitating this clear trend of moving, IT and OT closer together and using the one type of cable, for both types of networks, and of course facilitating IIoT, Industrial Internet of Things connectivity, are there other reasons why a manufacturer would want to replace field bus communications with Ethernet?
Yeah, I mentioned this earlier that there are special installation requirements for some field bus topologies. The cable, the connectors, splitters, repeaters, and all are bit sensitive to the installation practices. And we've been involved with a fair amount of field bus remediation issues that stem from really the incorrect installation practices or poorly executed field repairs. So obviously these issues cost time to debug and remediate. Not that Ethernet does not have these installation guidelines and sensitivities, but there seems to be a wider understanding of them, especially within the OT group, the engineering group, and maintenance group, as well as a larger effort by Ethernet device manufacturers to sort of design out those types of issues. Most system upgrades we've seen have some sort of field bus replacement with Ethernet as a part of a larger project, not as a primary reason for the upgrade, but usually as a good practice while going through and doing the other upgrade tasks.
Okay, so it's usually part, as you're saying, part of a bigger project, not a one-off sort of application type of implementation.
Right, right. It becomes secondary and something that is looked at as this is an enhancement. We should be doing this as we do these other things.
So let's say you're working with a manufacturer on the construction of a greenfield plant. Nothing's installed. You can go in any direction you wanted to go in. And for this, let's consider this both from a process industry point of view as well as a discrete manufacturing industry point of view. Would you recommend field bus communications for any type of specific applications and Ethernet for others, or would you recommend 100% Ethernet at this point?
I have to consider some discrete I/O field buses, particularly like OSI and CAN, because they have more consistent response times, and they're very simple to use, very simple to implement. And you're not really talking about a lot of information. It's strictly I/O. The OSI and CAN bus, for instance, offer an inexpensive digital I/O bus and can be really attractive for applications like building maintenance or conveyor systems. But typically, there's an I/O mixture of discrete and analog. So once you get into that point of starting to introduce analog, then you start introducing information, and the information becomes more important. And if you're doing information on the analog side, you should be doing information on the digital side too. So Ethernet becomes more of a standard and more of a robust connectivity tool at that point. I should also mention that in installing Ethernet, one of the things that you do need to be cognizant of and look into is this a classified area, possibly needing for intrinsic safety? Because at that point, you might want to look at a field bus, because there are some field buses that are made specifically for those types of environments. Even though, yes, Ethernet can be used in those environments, but you have to make sure that you're getting the proper tools for Ethernet to use in those environments.
Okay, understood. And so just to clarify with your statements that you made there about the situation is, so it's pretty much the same, whether it's process or discrete. There's not much of a difference between one or the other vertical.
Not really, although we see it far more in the process side, because there's just so much more information that process industry is interested in their process, as opposed to discrete side, where they're just looking at actuations and motors and so forth. But to be honest with you, even those now, you can get a lot of information out of standard motor starters, contactors, whatever. And that information is invaluable if you are really using that information. If it's just because it's nice to have, you're missing the value of having Ethernet connectivity.
All right. Well, thank you for joining me for this podcast, Duane. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember to visit our website at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.